Welcome to Team 1's Fall 2023 project, Sprint, a 3D printer that aims to meet top speeds and top accelerations through the use of specific motors and mechanical design choices. Now, why do we want to make such a fast 3D printer? 3D printing is a great prototyping tool, and a step forward now is to make it quick and efficient. By increasing the speeds and optimizing the design, we can pursue rapid prototyping through the use of 3D printing. This 3D printer typically works using separate motors to drive the XY beams across the structure, allowing the printer head to freely move along the 2D plane at the top. However, to show how the system works at a lower level, we have a DC motor that uses cascading positional control to demonstrate general usage. The DC motor is controlled by an ESP32 and a motor driver, all of which has a potentiometer button and a limit switch connected to control the movement. The DC motor is set up to a bearing and shaft system that helps move the transmission belt seamlessly so that the XY beam is able to traverse across the 3D printer frame. To control the DC motor, we use the small handheld controller. The system is initially off until you press the button to which the beam can be homed. Once the beam hits the limit switch, the system knows the beam is homed and will await another button press to move to the next case, where the system can move the beam freely, such as during printing. Once the printing and movement is done, you can press the button again to turn off the system to restart the entire process. As stated before, this handheld controller is used for the DC motor. This handheld controller features a potentiometer and a button, which acts as our analog and digital inputs respectively. These two sensors are hooked up to the breadboard so that the ESP32 can process these inputs. Under the railing, the limit switch helps deal with homing and to watch out for cases that are unexpected. When the beam hits the limit switch, the system will know the location of the beam and can calibrate the location as home, which is great for initialization and when the beam moves unexpectedly. As for the stepper motors, the system is run on a Raspberry Pi, which allows for remote controlling so that the system can be controlled through another laptop that can give precise information to the already set up software. Other electronics include specific stepper motor drivers and fans that help with temperature regulation as the drivers get hot very fast. The stepper motors feature the same mechanical setup as the DC motor, as the mechanical structure proves to be the best so far for our goals. Here are some examples of what we have been able to achieve so far with our stepper motors and mechanical design. What makes our mechanical design strong for this usage is the shortened transmission belts. As shown, each side has their own belts, instead of a traditional single belt throughout the entire transmission system. Shorter belts reduce vibrations to prevent slipping and other issues. In addition, the use of two XY beams to move the print head instead of a gantry system helps reduce the weight load on one of the motors so that higher accelerations can be achieved with the same applied forces. Last, our shaft coupler, bearings, and belt pulley setup makes it so that the motors can move the transmission belt safely and with high efficiency. This setup reduces flexing and unwanted forces that could cause problems or slow down our movement. Overall, all these design choices work together to help our printer meet our goals of high speeds and high accelerations.